So let's look at what our problem would look like if we have partial fraction decomposition and our integral. So if I were to kind of jump straight down to the bottom, I could work with this integral. The thing is, looking at this integral, if I were to try to do u substitution, I would want to make the bottom ru. The derivative of that would be 4x minus 1. We don't have a 4x in the numerator at all, and although the 4 wouldn't be the problem, the minus 1 would end up being a problem. So partial fraction decomposition is what we're going to do. I can do the partial fraction decomposition inside of the integral, but that's a lot of notation, so a lot of times we end up doing the partial fraction decomposition separate from the integral. So that's what we're going to do here. So the first thing that we need to do is factor the denominator. So if I do 2x squared minus x minus 1, we need a 2x plus or minus something times x. We need it to multiply to -1, so I know I'm going to have a 1 and a 1. So now I just need to think about where my positive is and where my negative is. We are adding to get -1, so if I test it out, if I put the negative here, 2x times 1, this would give me a positive 2x, minus an x, which gives me a positive 1x, which is not what we need. We need a negative 1x. So that means this first one's going to be positive, the second one's going to be negative. 2x minus 1, so we have a negative 2x, plus an x, we get negative x. So, and then I know that I want to use my 0, so I'm also going to solve for my zeros while I'm looking at these factors. So 2x plus 1 equals x minus 1, so 1 is equal to x and -1/2. So now that I know my factors, I'm going to go ahead and take what we have already and we are going to plug it into our function. So I have x plus 5 divided by 2x plus 1 times x minus 1 equals a over 2x minus 1 plus 1 plus b over x minus 1. So just like before, I'm going to multiply both sides by the denominator. I don't necessarily need to show that's what I'm doing, but that is what I'm doing. When I multiply both sides by the denominator, I know that first part is going to just become x plus 5. The second part, we multiplied this first fraction by both pieces in the denominator. The 2x plus 1 will cancel each other out to make 1. So we get a times x minus 1 plus b times our other factor, 2x plus 1. Now that I have this, I'm going to go ahead and plug in those values that I have. So I have -1, or -1/2 and 1. 1's a little bit easier to work with, so I'm going to plug in 1 first. So I have 1 plus 5 equals a times 1 minus 1 plus b times 2 times 1 plus 1. So 1 plus 5 is 6. 8 times 1 minus 1 is 0, so I know that we're going to have 0 a's. So I'm not even going to write anything with it. And then I have b times 2 plus 1, which would be 3. So if I were to look at this, we have 2 is equal to b, 6 divided by 3. Now we're going to plug in -1/2. So I have -1/2 plus 5 equals a times -1/2 minus 1 plus b times 2 times -1/2 plus 1. Okay, I have 5. If I were to change it into halves, that means I have 10 halves. I take 1/2 away, so I have 9 halves. -1/2 minus 1, so we have a times -3 over 2. 2 times -1/2 is -1, plus 1 is 0, so b goes away completely, and I get this. Thankfully, they're both being divided by 2, so I'm going to multiply both sides by 2 to get 9 is equal to -3a. and then I'm going to divide both sides by -3. So -3 is equal to a, and then I take my fractions and I rewrite them. So x plus 5 over 2x plus 1 times x minus 1 is a, which is -3, divided by 2x plus 1 plus b, 2x minus 1. So when I do this partial fraction decomposition, I get that our original fraction is equal to 3 divided by 2x plus 1 plus another fraction of 2 divided by x minus 1. So we're going to take a second and we're going to now look at the integral. So now that I have this, I've just done all of this work to show that those two are equal to each other. So what we are going to do is we are now going to take the integral of each of those fractions. So instead of taking it of that bigger fraction, we're now going to be taking the integral of this. So one of the things that we can do with our integrals is separate them into the integral of each thing. So -3, 2x plus 1 dx plus the integral of 2 over x minus 1 dx. I'm going to pull out any constants to make it a little bit easier. -3, the integral of 1 over 2x plus 1. 2, the integral of 1 over x minus 1. Okay. Whenever I see 1 divided by something to do with x, or just a fraction in general, I want to think about natural log. So if I were to make u 2x plus 1, the derivative of that would be 2, which means I'm missing that factor of 1/2. So our integral of this would be -3 times 1/2 the natural log of the absolute value of 2x plus 1. And then we are going to add it to 2 times the integral of 1 over x minus 1, which would also be a natural log. I would make u x minus 1, the derivative of that is 1, and we have that. So we have the natural log of the absolute value of x minus 1, and then of course our integration constant, c. I can simplify it from here if I want. The only thing I'd really do is the -3 times 1/2 is -3/2, but that's going to be about it. I just want to make sure that we have our absolute values in the right spot, our parentheses in the right spot, and then that's going to be it. And we need those absolute values because we can't have negatives in our natural log.